Okay, so here's another example, a little bit more advanced example um, than the card one that we just did. This is drawing two colored marbles without replacement. So we have a painted jar containing four red, three white, and two blue marbles. You select two marbles at random, one at a time, without replacement. So let event A be red on the first draw, and let event C be white on the second draw. So find the probability of getting red on the first draw and white on the second draw. So we're using the symbol for intersection, but that's compatible with also using the word and. So what's the order of A? How many reds do we have on the first draw? Well, that's going to be four. Now, how many whites are we going to have on the second draw? Well, since whites weren't selected in the first draw, we're just going to have the same number of white, so that'll be three. And then what's the order of our sample space? Four plus three plus two blue. So that's where nine comes from. So here's our answer. So part one, are A and C independent? No, since we're dealing without replacement being used. Okay, therefore we have to use the dependent form of our multiplication rule. But how we apply this kind of given probability is not going to be in the way that we would define it like this. Okay. But instead, just to maybe imagine this in a common sense way, but also in a very structured way. So what I've done here is I've set up two Venn diagrams, one positioned above the other. So you can see the first Venn diagram is the circumstances that we have surrounding our first marble draw. And then the second Venn diagram underneath are the circumstances that we have surrounding our second marble draw. Okay, so on our first draw of a marble, what have we got? What are the numbers of everything we're dealing with here? Well, we're dealing with a bag of nine marbles, and we've got four red, and we have three white. Now we end up selecting a red. Okay, we end up selecting a red on our first draw. So the first thing you'll notice is that the number of reds went down from four down to three on our second draw. But the number of whites remained unchanged. But now, since we're drawing marbles without replacement, our sample size is dropping from 9 down to 8. So this is the scenario that we've got going on with our second draw, and up above is the scenario that we have going on with our first draw. So in our first draw, what's the probability of getting a red? Well, it's the order of red over the order of the sample space. And there's four reds out of a bag of nine. So it's 4/9. And what we're calculating here is this first part. Now, the second part, right here, that's what we're doing here for the second draw. And so how many whites do we have for the draw of the second marble? Well, we've got three. Well, what's our new sample space? It went down from 9 down to 8. So the probability of getting the second marble being white is 3 out of 8. So the probability of getting red on the first and white on the second is going to be 4/9 times 3/8. be equal to 1/6. Um, and so that's the end. Is the probability of getting a red first and a white second is 1/6. All right. Let me know if you have any questions.